Hi, today we're going to be looking at Math MIU 1, Unit 1, Lessons 2.3 and 2.4. What are we learning? Well, we're learning how related multiplication problems can be solved by looking for patterns and using multiples. So let's first start off by looking at a problem. Mrs. Johnson's class counted around the classroom by threes. What number did the fourth person say? Well, if we're just doing the multiples of 3, we could look back on our chart and we would know 3, 6, 9, 12. Is that the fourth person? 2, 3, 4. So the fourth person said 12. Then I can look at this next person. The fourth person said 12. I'm just going to put that. I could also say that since this is the fourth 3, that is 4 times 3 equals 12. So now let's look at this next problem. Later, the class counted around by 6s. What number did the fourth person say? So let's count by 6s. 6. You can look back on your chart. 12, 18, 24. Fourth number? 2. Fourth person, I mean. 4. It is the fourth person. So the fourth person said 24. So let's think again about the multiplication problem. It's 4 groups times how many are in each group? 6, and that equaled 24. So now how does this relate to the problem on the previous slide? Both of them had 4, the fourth number, right? Both of them have an answer. One is in groups of 3 and one is in groups of 6. What do we know about 3 and 6? Well, 6 is a double of 3. What about 24? How does that relate to 12? Is 24 a double of 12? It is. So since they have the same number of groups, and this number here, 3 and 6 was a double of 3, then the answer is a double of 12. Let's try this one. Triangles have 3 sides. How many sides do 7 triangles have? So I can count by 3s. I can use my get chart as well. So I have 3 in each group, and I have 7. So that can help me write my multiplication problem. 7 times 3 equals, I don't know yet, but I can count by 3s. 3, 6, 9, 12, 15, 18, 21. 1, that's the 7th one. 6, 7. Oh, 7 times 3 is 21. How many sides do the 7 triangles have? 7 triangles have 21 sides. Now let's look at the next problem. Hexagons have 6 sides. Uh-oh. How many sides do 7 hexagons have? Well, let's do a get chart. So there's 7 groups because there's 7 hexagons. There's 6 in each group, and I don't know this. Let's write my equation. 7 times 6 equals, hey, look at this has 7 again, just like last time it has the same number. And then look, it has 3 and 6, and 6 is a double of 3. So I wonder if my answer will be a double of 21. Well, let's count by 6's and see. Let's see. Oops. 6, 12, 18, 24, 4 of them, 30, 36, 32. Is that the 7th one? Seven. It's the 7th one. So 7 times 6 equals 42. And let's see, does 21, because that was the answer here, does 21 plus 21 equal 42? 20 plus 20 is 40. 1 plus 1 is 2. 42. It is a double. I could have used that, and I wouldn't have even had to count out my multiples. There are 42 sides in 7 hexagons. Let's look again. Nancy and Philip were finding multiples on their skip counting charts. They circled 42 on the 6's chart. How many jumps of 6 did they do to get to 42? Ooh, this one's fun. Okay, so let's make our get chart. Do I know how many groups of 6 that I have? I don't. This is a trick. There are 6 in each group, and I'm getting to 42. So I don't know how many groups yet. So I have blank times 6 equals 42. Whoops, forgot the equal sign. So now I can count by 6's until I get to 42 and see what that is. 6, 12, wait a minute, do I know that because I just did that? 15, 24, 30. I feel like we just did that on the last problem. 42. Let's see how many that is. 1, 2, 3, 4, 5, 6, 7. So there are 7 jumps. Let's see. Deandra and Kenji circled 42 on the 3's chart. How many jumps of 3 did they take to get to 42? Show how you got your answer. I think we should, oh man, it's got the 42, and this time it's doing 3's, which is half of 6. Ooh, I want to use that. Okay. So first I'm going to make my get chart. It's got 42 total, 3 in each group, and I don't know how many groups. So I know that the 42 is the same this time. Let me write my equation. Blank times 3 equals 42. So I know the 42 is the same. It's not a double this time. And I know that the 6 and the 3 are double, which means this has to be a double. So whatever this number, so this one was double. So that means, I guess I'm going to have to count it out because this is kind of different. Okay, let's count. 3, 6. Okay, so I counted it out, and now let's see how many it is. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ooh, 14. How is 14 related to 7? 14, isn't 14 a double of 7? Took them 14 jumps. So this time, my answer, the product, was the same. And 6 was a double of 3. And then this other number swapped places and it was a double. Interesting. So I could use that to help me solve that and to double check it if I wasn't sure. Okay, so we've been talking about how the numbers are related and how they're kind of doubled. So we're going to look at the multiples of 3s and 6s and see how they're related. Okay, so here are the multiples of 3 and 6, and I've just put them right next to each other. And what do we notice about these? 6 is a double of 3, 12 is a double of 6, 9 plus 9 is 18, so it's a double. 12 plus 12 is 24, 15 plus 15 is 30, so these are doubles. 18 plus 18 is 36. So each of these match up as a double. Let's also think to ourselves here, they both have 18, but which one gets to 18 first? The 6s. Same with 12. They both have 12, but 6s gets to 12 first. And it gets there 1, 2, 3, 4, and this gets there after 2. So it's in half the time. Or this one is in double the amount of time. Same thing here. If I look right here, 1, 2, 3, 4, 5, 6 to get to 18. 1, 2, 3 to get to 18. And that's half the distance, or this one is double. So these are also connected that way as well. This can be used as a strategy to help you solve related multiplication problems with multiples of 3s and 6s, and also really other doubles, multiples of doubles as well. Same with 5 and 10.